Let us take two vectors, one is A, another is B. Then by definition of dot product, the dot product of vector A and vector B is equal to magnitude of vector A multiplied with magnitude of vector B times cos theta, where theta is the angle made between these two vectors. If this is vector B and this is vector A and this is theta, if we draw a perpendicular here, this is 90 degree, let it be O A B. In triangle OAB, which is right angle triangle, so cos theta is equal to base by hypotenuse. Here base is OA and hypotenuse is OB. So cos theta is equal to OA by OB. OB is the length of this vector, that is magnitude of this vector, which is A. So OA is equal to times cos theta. So this is the mathematical definition of dot product, where dot product of vector A with vector B is simply multiplication of magnitude of vector A and magnitude of vector B times cos theta, where theta is the angle made between them. So if we see here, we can write this as B times A cos theta. So this is the magnitude of vector B, but this component here is the axial component, of this vector A. So A cos theta is the axial projection on this axis. So mathematically we know dot product of two vectors is given by this formula, whereas this whole resultant is a scalar quantity, because this is a scalar quantity, this is a scalar quantity, and this is also a scalar quantity. So why do we carry out dot product? Why do we need dot product? So physical meaning of dot product is how much they point in same direction. If we see dot product of two vectors, let this be vector A and this be vector B. So if we draw a projection here, this length, this being theta, so this length, let it be OA. So OA will be equal to B cos theta. Here in definition we have A, B cos theta, where A and B are the magnitude of vector A and B respectively. If we see this vector in this direction, if we take this as a reference point, the vector is pointing in this point, whereas the component of vector B pointing in this direction is B cos theta. So the component pointing in this direction is A of vector A and B cos theta of B. Here we are trying to find how much they point in same direction. If we take a three-dimensional coordinate system, this being x-axis, this being y-axis, and this being z-axis, let I cap, j cap, and k cap be the unit vector along x-axis, y-axis and z-axis respectively. If we have a vector A, then vector A can be represented as Ax I cap plus Ay j cap plus Az k cap. Now let's take another vector, vector B, which can be represented as Bx I cap plus By j cap plus Bz k cap. If we find dot product of these two vectors, it will be equal to Ax into Bx plus Ay into By plus Az into Bz, because when we multiply Axi plus Ayj plus Azk and Bxi plus Byj plus Bz k cap, when we multiply with this, it becomes Ax Bx I. We know dot product is always given by A B cos theta. So theta is the angle between them. If I represents the same axis, x axis, so the angle between them is 0 degree. So cos 0 is 1. So I into I is 1. So it becomes Ax Bx. So it comes here. Now Axi plus Axi into Byj. It will be Ax into By I j, but we know I and j points in x direction and j points in y direction. They are perpendicular to each other. So cos theta, that is cos 90, is 0. So this whole term becomes 0. Similarly, when we multiply each other again, the whole terms become 0. Only I, J, and K remains non-zero. What are the properties of dot product? We know vector A with dot product with vector B is equal to AB cos theta. 1. If theta is equal to 0 degree, then cos 0 is equal to 1. So dot product of A and B is equal to AB, where cos theta is 1. So this is the maximum value of a dot product. If theta is equal to 90 degree, cos 90 degree is equal to 0. So A dot B is equal to AB times 0, which is equal to 0. If theta is equal to 180 degree, cos 180 degree is equal to minus 1. So dot product of these two vectors will be equal to AB times minus 1. So it is equal to minus AB. This is the minimum value of a dot product of a vector, of two vectors. As we know, dot product of these two vectors is a scalar quantity, thereby there is no direction at all. So A dot B is equal to B dot A, because if we find dot product of this, it is AB cos theta and this is BA cos theta. Both are equal. Thereby this equation holds true. This property is called commutative property. The dot product obeys distributive laws. Vector A times vector B plus vector C is equal to A dot product B plus A dot product C. Dot product of a vector with itself is equal to A times A cos theta. Here theta is equal to 0 degree because the both vectors are the same vectors. So cos 0 is 1, it becomes A square. So the dot product of the same vectors is equal to square of the magnitude of the vector.